one is. Why is my chat not coming up? Oh, okay, here we go. Hey, all right, so this first one, I've only heard from 3 people. Kick somebody out here, they're being rude. Okay. All right, looks like you guys have all answered in. Yes, it's totally ANOVA. So good job. And how do you know? Because there are categories across the top, which actually aren't really categories, they're really actually groups, which group you fall in, and then based upon what group you fall in, your data will go into that group. So there's no categories along the side, right? So if there's categories across the top and the side, then we'll be looking at one of the chi-squareds. All right, so let's go and take a look at this one down here. Which one is this one here? Text me, private text me, private chat me. Heard from 1 person, 2 people, 3, 4, only 3 people. This is troublesome. 4 people. Come on, guys. This one right here. Which one is it? This one that my mouse is on. This one here. What kind of chi-squared? Is it the matrix or is it the line? They're different. Okay, so this one is a chi-squared matrix. Because you can see there's categories up top and categories along time. This is not, male and female are not observed and expected. They're not the same thing, only one you observe and one thing you expect. They are 2 different things. Being a male and being female are not the same thing. So these are 2 different things. There's categories along the top and along the side. That's the chi-squared matrix. So my matrix is right here. How about the bottom one? What's this one? Text me, guys. Let's not take forever, please. Two people, 3. So from looking at this, you should be able to tell, just from kind of how the data's flowed out. Right, the top one, there's categories across the top, but not along the side. So this is not a chi-squared, because chi-squared should have categories here and something here also. Right, in this case, it has, this top case, it has categories here and categories on the side. Here it has categories across the top, and then it kind of gives you some observed here. So this is my observed and my expected, not categories. So this would be a chi-squared list. So that's how we kind of tell those apart. That's how we tell apart the chi-squareds from the other ones. It has categories across the top and kind of categories along the side. If they're definite categories, then it's a chi-squared matrix. If it's observed and expected along the side, then it's just a chi-squared list. Or it might be where we have to put in the observed. But it's not like here where you have lots of numbers. You have categories across the top and lots of numbers going down. This is 3 lists, which is a little bit easier to tell. All right, the last one on the far right. What's this one over here? Only 1 person? It's really important you guys be able to tell these apart. It's going to be serious trouble if you guys can't. Only 3 people, 4 people. All right, so your first question is, Your first question should be, are there categories across the top and the side, or just along one or the other? And here, there's nothing along the side. There's no categories. There's only along one or the other. So then, you know, it's not along both, but there's stuff, you know, along both. Because if you kind of look at it, the thing about the list is the list only has, you know, 1 or 2 things of data here, and there's labels on it. Here, there's no labels that label these guys. So that's kind of another thing. So that means that this has to be either, if it has 2 of them, then see if they're matched up pairs, in which case it's linear correlation, linear regression, correlation regression. And then if it's 3 or more, then it's ANOVA. But if it has stuff kind of along the top and the side, then we're looking at it being a chi-squared. Oh, let me go back and erase this. So these are, so the way of kind of helping you sort these out and figuring out what kind of problem we're looking at visually. All right, so let's take some shots at this. Kind of gave it to you already, didn't I? What kind of problem is this one? Mm-hmm. It's a matrix. How do you know? Data across the top, data along the side. If there's labels across the top and labels across the side, sorry, not data, labels across the top and labels across the side, then it's a chi-squared matrix.
Professor Young, I'm not sure if you're seeing these comments by whoever, but they're being really rude.
I know. I'm trying to figure out how to keep them out, and that's my problem, is that I can't. Let me try to, I'm going to leave this open and see who becomes something else, and then they're going to be in serious trouble. So I'll just do that, because I have a list of all of the people, and I'll just keep my eye out for that. Who changes their name? Okay, because that's totally rude and inappropriate and wrong. Okay, so labels across the top, labels along the side. This is our matrix. And I mean, especially you guys should totally be thankful to Jay, because she's totally saved me from giving everybody misinformation before your exam, so you'd have all messed up stuff on the final if she hadn't, like, saved me from totally screwing up. Okay, all right, so here we've got a matrix. Let's go and take a look at the next one. So how about this one here? What do you guys think about that one? I'm going to read it.
Do you want us to type it to you, or just?
Yeah, go ahead and type it. That's fine. I'll try to bring up both these 2 things at once. There we go. Oh no, no. Okay. There. All right, good. So this one is linear correlation. How do you know? Well, you have the verbal cue. It says linear correlation. But the visual cue should be that there are only labels along one, not along both. Do you see what I'm saying? So that means that it has to be either, if it's 3 or more lists, does not look like 3 or more lists to me at all, so it must be X and Y. Good? Okay. Next one. Blank this one out. What's the next one? So I want you guys to take a look at this one. I've heard from 1 person, 2 people. Who's the anonymous? Okay, so I think you guys sort of have this one. This one's ANOVA, right? You've got categories across the top, but not along the side. Also, it says mean. The means or the averages have to be ANOVA. So there's nothing along the side here. So it can't be a matrix, because a matrix would have to have something along, labels along the side as well. Okay, take a look at this one. All right, so what do you guys think for this one?
The chi-square list?
Yep, chi-squared lists. Yeah, most of you guys got that one. Sorry, I'm distracted. I'm trying to hunt down people who shouldn't be here. Okay. So this one is a chi-square list. It's got a list of days observed, right? And so then here they are. Here are my categories: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And then we're going to take these observes. You're always given the observes, and you have to put them into your table. And then you always have to calculate your expecteds. So expecteds, you always have to calculate those always. Here, we're going to say, let's see, they are the same frequencies. So they also didn't give me percentages, so that means I'm just going to take the total, and I'm going to add up all these numbers, 114, 152, 160, 164, 179, 196, and 130, and divide by 7, because there's 7 days. So I'll divide equally amongst them. Yeah, you want to take a picture of the one where the tables were and what you wrote, what each table was. Yes. You guys do know also that all these are on, they're going to be saved on Canvas. So let me go ahead and run back to that one. I'll put that one up during the break. How's it sound? We're going to take a break in a couple minutes. So this is what we're going to do when we get back from the break. We're going to do this problem here. So take a picture of it now if you can, because it will be gone soon. And what happens, and then during the break I'll put up the picture of the of all those different types of data pictures so you can kind of look at them. All right, so now, uh-oh, where's my thing? I'm going to stop sharing.